This is a most amazing piece of equipment. It is a dual channel arbitrary waveform generator. What I have programmed is a burst of sine waves, 74 cycles per burst at a frequency of 1.85 megahertz and a burst period of 40 milliseconds. If that looks familiar, it is. It's a LORAN master station signal pulse train. 40 microseconds long at 1850 kilohertz is 74 cycles of RF. So you have 74 cycles of RF, and it's repeated every 40,000 microseconds or 40 milliseconds. Okay, here it is. There should be 74 pulse trains there, and then they're over. And if you want to see them, those are the pulse trains, 40 milliseconds apart, very narrow. Now on the second channel, I have programmed exactly the same thing, except this time I have put a delay of 22 milliseconds to simulate a half PRI plus a delay. And this is what this delay time is what a LORAN receiver is supposed to measure. So in my case, it should measure 2,000 microseconds if we had a LORAN receiver. I can make this anything I like. Okay, you can program this. So this could simulate distances in half-mile increments in the Atlantic Ocean. That's what this is simulating. So obviously you don't see it here because it's now delayed. So we're going to go back to the original, or the wide sweep here. Takes a while to get the samples loaded in. There they are. Look at them. The top line is the master pulse train. And you can see after half the PRI plus 2,000, in this case 3,100 microseconds, that is the actual delay time for navigation purposes. So there we have it. Now, this device is very powerful. It'll provide 20 volts peak to peak into 50 ohms. We're talking about a watt of power. I've got my coax cables and I put some small antennas on here. We're tuned to the 160 meter ham band at 1.85 megahertz center screen. I'm now going to turn on the LORAN master and LORAN slave transmitters. This is the first LORAN A station in Canada since 1980 on the air. Here's an overview of the LORAN stations in the North Atlantic. You can see that there is a master station at the tip of Greenland called 1L4. The 1 signifies 1.95 megahertz in the 160 meter band, and the L4 signifies a pulse repetition interval of 39,600 microseconds. And the corresponding slave station is in Labrador, 1L4. There's another pair of stations, a master in Nova Scotia, 1H1, and a slave at the southwestern tip of Newfoundland, 1H1. H1 signifying a pulse repetition interval of 29,900 microseconds, but on the same frequency, 1950 kilohertz. Now we're going to look at an actual LORAN navigation chart. This is Newfoundland here. And that station, the 1H1 slave station, is right there where the mouse is. And the master station is in Nova Scotia, 1H1. And you can see there are hyperbolic curves between the two stations. And then there's a baseline which basically intersects the master and the slave. If you're behind the slave on this line, you're going to get a constant time delay because the master has to send its signal to the slave, and then the slave will send its signal out. But it'll be a short delay compared to when you're behind the master on this side down here, because then the master has to send the signal up there and the slave has to send it back and then to you. So that's why here on this curve you see 3026 microseconds, whereas on this side up here you see only 1000 microseconds. And everywhere in between on these brown curves, that's the ones we're looking at for this station, you can see 1400, 1600, 1700, 1800, 1900, 2000, 2100, 2200, 2400. These are the microsecond delays between master and slave, actually between the half PRI time of the master and slave and then the slave actually transmitting. So you would interpolate between these. If your receiver said 2132, you could actually calculate within a half a mile of where your ship was or your airplane was. And this will also work for skywaves. There is a skywave correction on this chart for each of the stations. These plus numbers up here, -1, these numbers up here, these little numbers. These are skywave corrections for the different colored curves because of the added time to the ionosphere and back, which is quite short. I mean, it's like 100 miles or so compared to these 1,000-mile navigation curves. So it covers all the way to England. There's a station in Iceland, and then there is a station here in the some islands here north of the UK. So this covers the whole North Atlantic. Very important for shipping before GPS, and especially when it's cloudy and you cannot use a sextant and sight by the stars and sun. So LORAN A was extremely important since World War II up until 1980. And then, of course, in the 60s, LORAN C came, which is at 100 kilohertz. It's a totally different system, although it still has master and several slaves, but they use phase detection to get you more accuracy. But the simplicity of LORAN A can't be beaten.